Hi students, coming to the next topic, that is a binary search tree. Now let us see what is this binary search tree. A binary tree is composed of, a binary search tree is composed of 0 or more nodes. So the one thing you have to be noted that whatever the binary search tree, that is a tree, is composed of 0 or more nodes, then you call it as a binary search tree. So here in binary search tree, each node contains the first one, a value. Each node contains a value. A value is nothing but some sort of data items, any sort of data items, a value, and a reference or a pointer to the left child. You call it as a reference or a pointer to a left child. Maybe null. You can take the null also. Maybe a left child contains a null value or it contains any data item value. And the third one is a reference or a pointer to a right child. Maybe a null. Okay. So whatever the node you have taken in a tree, that is a node. This you call it as a node. Suppose A is a node. Here a node contains a value, that is some sort of data items, and a reference pointer to the left child and a reference pointer to the right child. Reference or a pointer to the left child or reference or a pointer to the right child. Okay, so this left child may be it may contains a data value or it may not contains a value. Okay, next coming to a binary tree may be empty. You can take a binary tree may be empty. So without values it can be there. A binary tree can be constructed. In the starting I already said a binary search tree is composed of 0 or more nodes. It may consisting of 0 or more nodes. So that's why a binary tree may be empty. If non-empty means it has some root node. Suppose a binary tree is having some nodes. So the starting node you call it as a root node. If not empty, it has root node. Okay, so what is that root node? Every node in the binary tree is reachable from the root node by the unique path. So that a root node will be there. So whatever the node you have taken, that is every node in the binary tree. Okay, so whatever the node you have taken, so that has to be reachable from the root node by a unique path. And a node with neither a left child nor a right child, you call it as a leaf node. I am saying neither. A node with neither, it's not either, it is neither a left child or right child is called leaf node. That means if any node that is having no left and no right, then you call it as a leaf node. So here there is no left child and there is no right child. So this is a leaf node. And here also there is no left child and no right child. So these are also leaf nodes. And this is a root node. Okay. So a node with neither a left child nor a right child, you call it as a leaf node. Now let us see some properties of the binary search tree. Let me explain first the properties. After that I will explain with an example what exactly the binary search tree will do. Property. So what are the properties for the binary search tree? So first is for all nodes x and y. Whatever you have taken for all nodes x and y belongs to left subtree of x. So for all nodes x and y they are saying. So x is suppose a node. So here y belongs to the left subtree of x. That is here. The left y belongs to left subtree of x. Then the key at y is less than the key at x. So here whatever you are taking that value, this value, the y node value should be less than x value. So whatever the value that is less than x value, that should be keep from the left side. So less value should be left side and the more value, that is the greater value, should be right side. So here y belongs to the left subtree. Why it is belongs to the left subtree? Because the key at y is less than the key at x. And the next point. If y belongs to, suppose if the y belongs to right subtree, then what it is? Right subtree of x, then the key at y is greater than, it's not less, it is greater than the key at x. So here the x is a root node and here the y belongs to right of the subtree. That means the key at y is greater than the key at x. So these two properties we have to follow while we are constructing the binary search tree. A binary search tree means here whatever the values, that means the nodes that you want to insert. If you want to construct the binary search tree, if you want to construct the binary tree, you have to take it that all the nodes that are less than the root node, that should be present left side, and greater than the root node, that should be right side. So let me take the simple example here. A binary, let me take the example. I'm writing a binary search tree of size 9. So here I'm taking size 9. I'll tell what is the size 9 also. Size 9. And here are some constraints. With these constraints I'm implementing the binary tree. So a binary search tree of size 9 and depth 3 with root 8 and leaves are 1, 4, 7 and 13. Okay. So here they are given some constraint. What they are given? The binary search tree of size should be 9. The size of that means 9 means total it should have 9 nodes. The 9 nodes represents the size of the tree. Okay. And depth 3 means up to 0, 1, 2, 3. It can goes to up to depth 3 with root node 5. And the leaves means there is no left child and right child. So for 1, 4, 7 and 13 there should not be left and right child. So let me construct this. First 8 is the root node. They are saying that root 8. So 8 is the root node. And the left should be less than 8. So I have written 3. And the right should be always greater than 10. So here I am writing whatever the number I want, but the leaf nodes should be this. So left is less than the root node and the right is greater than the root node again. So 1 should be less than the 3. So left side, and the right side is, I am writing the 6. Okay. So here 1 is the leaf node. So don't extend this because the leaf node doesn't contain any left child and the right child. Now coming to 6. So I'm taking 4 is a leaf node. So 4 is less than 6. So that's why I have written here. And here the 7 is greater than 6. So 1, 4, 7 are the leaf nodes. Now coming to this. 14 is greater than 10. And 13 is less than 14. So here the depth becomes 3. Why depth is 3 means here this is 0, 1, 2, 3. Means the level of the nodes, the level, this is the 0 level, this is the first level, this is second level and this is the third level. Means the depth is 3. So the depth indicates the distance from the root. You call it as distance from the root. So distance from the root is depth. So from distance from the root 1, 2, 3. Okay. And the size indicates number of nodes present in the tree. Number of nodes. So total how many number of nodes are present? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the size is 9. So this is how you construct the binary tree. So this is the algorithm you have to follow, means the property that you have to follow while you are constructing the binary search tree. Thank you.